I'd like to present to you two of our projects that we are doing now. One is both actually are towers, done by KPF and SOM and their team. They both share the same area program, a mixed-use program, but they take a very different approach in the design to meet the challenges. Okay. Guangzhou, capital of Guangdong province, is China's third largest city. And inside Guangzhou, we have a lot of art, culture, and lifestyle happening there. And there we have our CTF Guangzhou, meaning Chow Tai Fook Guangzhou Tower in Guangzhou. Situated to the west of this axis, here you have the Zhujiang New City. And here is the Canton Tower, Guangzhou, CTF Guangzhou, and the IFC. Together, we set a pair of a gateway into the Zhujiang New City. Around this Zhujiang city, we have the Guangzhou Opera House, Guangdong Museum, Guangzhou Library, and our tower. So in fact, Zhujiang New City is fast becoming the CBD of Guangzhou. The tower and the podium will house a Grade A office, service apartment, luxury hotel, and the retail mall in the bottom. The building takes the form of a spiraling steps that runs from the podium up to the tower at the top there. And taking advantage of these steps, we house the ballroom, function rooms, all these things in the bottom here. And there you have a different in function from office, change to service hotel or service apartment, and then the hotel at the top. The steps also recognize the varying height of buildings around us. You see that these steps here actually react to the height of the other buildings around us. And because of the steps, we're actually taking advantage of the open space where people can come out and extend from interior to the exterior, where you can enjoy the spectacular view of Guangzhou city. When you go up to the office, this is a sky lobby. The hotel arrival, hotel amenities, rooms, and all these things. Apartments. You have library and studio and 1-2 bedroom suites. Our retail mall advocates art, people, and nature being the three main elements in terms of shopping experience. We have a 9-story podium here. The elevation of the tower is designed to accentuate verticality. You'll see that these lines are actually made of terracotta tile that runs from the bottom to the top and wraps around the building. These terracotta tile actually hung some half kilometer up in the air. We have to make sure that it is really safe, and therefore we have done a lot of destructive tests to make sure that when they really get impacted by different loads, they will stay there, right? In fact, terracotta dates back in the early history. And in the 20th century, has been very popular in the States as a building material. Here, KPF has used this to apply this ancient art in Europe and those in the Chinese ways. In fact, they like to marry the two, the art in historical culture of China and modern day engineering. The building itself is supported by a square core in the middle with 8 mega columns surrounding it. Why we adopted the mega column system is because of the panoramic view that we can offer to the occupant. The core and the mega column rest on a big foot. We call it a pad, and then a raft. These actually are socketed into bedrock. The whole tower is supported with four outriggers that extend from the core to the skin. And there are 6 sets of double layer belt trusses all the way to the top. We have been using C80 concrete for the lower floors of the core and the column in such a way that we can actually reduce the thickness of the core wall by as much as 300 mm. And the whole system has been tested with shaking table to the maximum of 60-ton height of weight in Beijing. The test actually was very successful. Let's go to Tianjin. CTF Tianjin is designed by SOM and his team. The design of this building actually follows very strictly with the area program and the integration of structure and architecture. CTF Tianjin situates in Teda, is the outer city of Tianjin, and in the axis of the Teda district, which is the CBD of the area. We have the 3 major functions in tower: office, service apartment, and hotel. You see that because of the area program, you see that the tower is being tapering up from the office to the hotel. The office floor plate of 3,800 square meter offers you a knee span of 13 to 15 meter, which allow ample daylight into the occupant area. In the service apartment, we have a 12 to 13 meter leaf span, and then up to the top of the hotel, we reduce down to 1,800 square meter, which is a very efficient floor plate. So when we stagger the 3 functions together, and together with the sloping column, the building form evolved. The external skin of the building is composed of a U-shaped channel. This U-shaped channel actually offers a very nice circular solid surface to reflect the daylight in the daytime and glow in the nighttime with its own built-in LED. And this offers also the way to stagger the glass in such a way that you form the curve. We have done rigorous optimization due to the fact that with this curvilinear wall, we have something like 25,000 number of window units, and they're all different. So by optimization exercise, we have reduced the number of unique panels down to 339. The architect has also studied rigorously on the way to use cold band glass instead of staggered flat glass. But the cold band actually go all the way to 53 mm. It is very, very high. And it actually exceeds the capacity of most of the suppliers. We also started with a very irregular shape down to isosceles trapezoid form and rectangular forms, and they're put together in alternate panels. Let's go in the interior of the tower. This is the office entrance, following the curvilinear aerodynamic form of the building. The sky lobby of the hotel, and the futuristic interior of the retail mall. Again, this is a 530-meter tall tower, supported by a reducing square core up to the top and a series of sloping columns around it. The whole tower rests on a 5.5-meter thick pile cap and some 400 odd friction piles. We did not employ any outrigger. I think outrigger gives you a problem in terms of construction. What we have is, in fact, only 3 series of belt trusses and 1 head truss to support the crown. And at the bottom, you see a major cantilever glass canopy, which is supported by post-tension tendon. Here. There are 2 canopies here. Each one is a 20.6 meter cantilever out without column, and then these are suspended by post-tension cable, which is a very, very clever design and very beautiful. Okay, making use of the aerodynamic shape and a porous crown, in fact, we have reduced the wind load to the minimum, so that, in fact, the whole structure, the design of the structure does not have to take care of the wind load, but only the seismic load. Eventually, we have a shaking table to verify the design, which is very efficient. In terms of the building services, both towers share the same sort of the challenges because of the sheer height. The building is compartmentalized or subdivided into zones. You can see that the number of zones, meaning that actually we have different supports in each of the area, so that each of them will function independently and efficiently. Here in Guangzhou Tower, we have probably the world's fastest elevator for the hotel. This is a 20 meter per second elevator, probably the first one in. Well, to ensure comfort, riding comfort and safety, we have devised several features like enhanced roller guide to make sure that it doesn't really shake too much when it really runs at that speed. We have streamlined cab enclosure to reduce the wind noise. We have double wall cab enclosure and solid fill cab doors. All these actually try to enclose the building from noise. And we also take care of the air pressure inside the cab. When you're running downwards, we would start to activate the pump system so that it will be pressurized before it starts to run down, or otherwise, or vice versa. Due to strong wind, the building is going to sway, and there are sensors built in the shaft to detect the sway of the building. So to a certain stage, the signal will be sent to the system to either slow down the elevator or stop it at the nearest floor. In terms of fire safety, we have a 720 cubic meter water tank put on top of the tower. That is to ensure that even if, in case of whatever failure, water is still there to support the firefighting. And fire evacuation as well, that we have a evacuation elevator of 3,500 kilogram to bring the occupant from level 688 down to level 1. Well, stack effect, like a chimney, these two towers are going to give you temperature, pressure problems. You know? And we examined the two projects, one in Guangzhou, one in Tianjin, and the temperature difference, ambient temperature difference in Tianjin is very big. It's up to 40 odd degrees Celsius. And that will give you a 600 Pascal potential differential air pressure. So what we have done is to avoid the heating system being impaired, we have radiant floor heating. For the lift door, normally, these are, there are difficulty to close or open the door, though we have this upgraded specification for the lift door, and exhaust fans in series, and of course the air fans equipped with volume control to make sure that the air pressure will not counteract our exhaust system. Today, our Guangzhou tower has been topped out, and then we are going to enclose it. In 4.5 years' time, this will be completed in operation. Whereas in Tianjin, we have already completed the foundation system. We are starting to build the basement now. Well, I think I'm not a designer, but we are thankful to KPF and SOM of their innovative design, and their team has been doing a lot of work for which we are grateful.